points. Okay. I know. I've got great hearing. That's why I asked. Okay. So there's B. There's B. So this one, granted, I didn't reorganize. It should be 2x plus 21y is equal to 19. A is 2, B is 21, and C is 19. Okay. If you have questions as we go through, you can either stop me or I will ask for questions at the end as well. B, number 6. You just multiply everything by 5, get y by itself, and you get y is equal to 12/5 x minus 9. All of this stuff is, honestly, when I wrote the test, I grabbed this and then wrote out kind of things really similar. So I did put a couple other things on there, but this is kind of the guide as to what it's going to look like. 8. We've got y is equal to 65x plus 82. 82 must have been the original balance, and then A65 is the savings per week. Question, just random question. I like to ask every once in a while. How many of you guys, this makes me think of savings stuff, how many of you guys have a savings account with at least $500 in it? Okay, good. Okay. It's, for me at that age, I was not disciplined or mature enough to set anything aside. If I earned it, it was gone. I mean, my grandma could give us $2 bills. I don't know, that's one thing she always liked to do. I would take them right down to the arcade, turn them into quarters, and they'd be gone by the end of the afternoon. So I'm much better at saving now because my wife makes me. Okay. 10. So 10, got this scenario. 3.25, the reason I divided that out like that was to, because I thought it was money. So let's go ahead and divide that to 3 1/4. Okay. So anyway, so I got this all down. 3.25x plus 52. 52 is the yearly membership fee, and $3.25 for the amount you pay each time you go. I don't know, you guys, is this a realistic problem? Would you go to a museum 15 times in a year? Most likely not. Yeah, maybe once or twice. Some museums kind of rotate their stuff quite a bit, but I don't know. Anyway, I just like to critique these problems they write a little bit as well. Okay, here we go. Bottom one. Y minus 11 is equal to negative 2/5 x plus 3. If I put something like this on the quiz, on the test, those should be free points. Free points. Okay. Number 18, up here. Way up here. I did, first of all, you got to find your slope is 4. And then I did, I used the point negative 3.6. If you use the point 5.2, it would be y plus 2 equals 4 times the quantity x plus 5. Both are going to yield the same thing. Right underneath this, I used 3 and 174. My 3 came from its 3 hours after they opened at 5, or when they started keeping track of it. And then 5 was 5 hours after they started keeping track. And 58 is 58 subs per hour. Question, is Subway on your top 3 places in West Point to eat? Raise your hand if it is. On your top 3 favorite places to eat. 3. Top 3 here in town. Okay? Okay. Mine, without a doubt, favorite place in town, Pizza Ranch. What?
District. It's on Main Street. It's a nice restaurant. You should go.
Oh, really?
It's They have like a
It's
pizza
good.
burgers.
Their pizza.
Do they have steaks and stuff too, or not?
I don't think so.
Okay. Okay. Might have to. What's it called again? District?
Yeah.
Okay. Okay. Well, I might have to consider that one of these days. Okay. Okay. On the back. Here we go. Okay. I'm going to ask you guys to know this stuff pretty thoroughly. Did I miss something? Okay, I thought you were going to ask a question. Okay. No, you're fine. This one has one solution. How do I know? Because my slopes aren't the same. If my slopes aren't the same, they're always going to intersect. They're always going to intersect. Okay? The next one, my slopes are equal, but my y-intercepts are different, so they're going to have parallel lines. They're never going to intersect each other. You can tell 2x and 2x. My slopes are the same. My y-intercepts are different, so they hit at different points, but they will run along next to each other like train tracks. Okay. On 9, and where did I put my work on number 9? I just did this one. Come on, Rex Road. Did I throw it away? Gosh dang it. Well, I'll tell you that this one here is 1, -3. Disappointed that I've misplaced that. Oh, okay. Here we go. 1, -3. They're right down here. Okay, your graphs need to look like this. And then the next one, your graphs look like that, so they are parallel to each other, no solution. Okay? So make sure that you can graph those and find points of intersection. Should be no surprises on the quiz tomorrow, or on the test tomorrow, whatever you want to call it. One thing to remember, review problems in the morning, come on in. They're helpful for you.
What did you say the point was with intersection? Would it have been negative?
-1, -3? Yeah, I'm sorry. Did I forget a negative? Yeah. Yep. That was kind of silly. Yep. So -1, -3. Honestly, to be totally honest, it wasn't really very clear. So what I did was I snuck over here and solved it algebraically. So just to make sure that I was getting it right. Okay, anything from here you want to talk about? Otherwise, we're going to get going on some new information today that is not on the quiz tomorrow. We've reviewed plenty. Okay, you can put that stuff. Oh, the worksheet. A roaring fireplace. Okay, if what? A friar? Yeah, there's somebody who they're studying religion and they live in a monastery. Okay, that's what a friar is. Okay, and see, so and then it's supposed to sound kind of like a roaring fireplace. So, okay, put that away. Grab whiteboards, please. Hurry up! Hurry up! Hurry up! You guys are on it today. Yeah.
Because I wrote it differently.
Mm-hmm.
So I have it put like that. And I came out with a negative, and you have a negative 1 point. Because I just kept in the points. I don't know if I had to switch it to without points.
Okay. That's a great question. Let me answer that to the class, okay? Thank you. Okay. Yep, that's all right. Zach asked a good question. Okay. On number 2. He had it written differently and wanted to know if it was okay to have it written differently. The rules on standard form, we can't have fractions and we can't have decimals. Okay? So they need to be integers. 1, 2, 3, 4, negative 1, negative 2, negative 3, stuff like that. And your A needs to be positive. Okay? So what I did was I went ahead and multiplied everything by 10. And then I said, okay, you know what? Since my Y is already over there and I need this to be positive, I scooted it over this way. Brought my 19 over. So your A needs to be positive. No fractions, no decimals in any of those. Good question. Thank you. Okay. So today, what we're going to do is I'm just going to give you a little visual heads up on what's going to happen here. Our graphs are going to look like this today. Or look like this today. Or look like this. Okay? Where before what we had a linear system of equations. We had a line, we had another line, we want to know where they were equal. Okay? That one and only point was the solution to the system. Today, our solutions are going to be a shaded area instead. So we need to review back to drawing inequalities. So here we go. I'm going to ask you guys to do some warm-up problems here for us, folks. Here we go. Y is greater than 2x plus 1. Graph, show me. Kind of close. Something's wrong with your line, though. Kind of close. Something's wrong with your line, though. Your line is good, but you shaded the wrong direction. Your line is good, but you shaded the wrong direction. What did you do to your line? Your line should be dotted. Line should be dotted. Perfect. 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 Okay, so here we go, folks. I just did this real quickly, real sloppily. It looks like some of you guys drew this better than I did. So this one is plus 1. So I started at 1, went up 2 over 1. So there's my line, and I've got a dotted line. Why is it dotted? Because it's not equal to. So if we were graphing things on a number line, we used open circles, right? Well, this is the equivalent of an open circle. That means that this divides the points that work. The points that work over here, the points that don't work live over here, and the points on the line themselves don't work. Okay? Try another one. Y is less than or equal to negative 3 halves x plus 2. So far, so good, folks. Sorry. Sorry, I didn't realize I was outside of the... Yeah, that looks good. Good. Okay, now just shade it. You got to shade one side or the other. Good, good, good. You guys, good. Your line graphing has come so far. I'm pleased. So here we go. Okay. Let's do another one. X plus Y. Yeah. X plus Y is greater than 4.
Do you have to get y by itself? No, you don't have to. Can you? Yes, you can, but you don't have to. If you don't want to get it by itself, think about what your x-intercept and your y-intercept would be. Perfect. Beat him. There you go. Oh, dotted. Good. You're shading. Good. Awesome. Sweet. Nope. Because remember, there's my y-intercept is 4, my x-intercept is 4. Don't forget to shade. Your line is perfect.
It's bad. Sorry. I was only
Good.
reading properly.
Okay, so here we go. Here we go. Don't forget that you can find your x and y intercepts just by plugging in 0 for x. That'll give me 4 for y, the point 0, 4. If I put in 0 for y, that'll give me 4, 0. I've got that. How do I decide on this side, which side, on this one, which side to shade? Test point. What's a good test point to pick? 0, 0 is a great test point to pick. Nice. You guys are having a rockin' day here. That is false. So that is the losing side. Kind of like the seniors or sophomores in the spirit stick. So we're going to shade over there. Okay? It was perfect. Okay? 2x minus y is less than or equal to 5. Okay. I'm going to go ahead and show my answer, but I'm just going to put this up here so you can see how I might get y by itself. If I subtract 2x, divide by -1, so now I got to flip. Some of you guys had your slope wrong. Okay? So my y-intercept is -5. My x-intercept is 5/2 or 2.5. And it's going to look something like that. I shaded that way. It's weird. 0, 0 does work, so I shaded that way. Here we go. Y is greater than 1. Good. Good. And we have one more. That's x is greater than 1. Good. I think you have less than. Good? 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 Good. So here we go on this one. We've got y equals 1 is this line right here. And greater than that. This last one. Y is greater than x. Whoa, this one always throws people for a loop. But you can still look at it as a slope-intercept. My slope is hanging out there in front of my x. My intercept is hanging out behind my x. Dotted. Good. Y is greater than. Good. So remember, this is like saying y is greater than 1x plus 0. If you're one that really needs to see that intercept and your slope, there it is. Perfect. Perfect. Don't forget to shade. Zero, zero, up 1 over 1, dotted, y is greater. Okay, so now here's the deal. I've restocked our graph paper a little bit. I made some copies of some double-sided, the smaller graph paper. I think that's what you guys probably like the best. Okay. We still have a bunch of copies of this where there's 12, crammed in there. But I made some new ones today that are a little bit bigger, and there's 6 on each side. The reason why I mention that right now is let's be efficient as you guys are bringing your whiteboards up and stacking them nicely. And bringing your Kleenex over and making a nice pile of non-snotty Kleenexes. Pick your graph paper that you will use for today's homework and also ones we're going to practice here. No. Okay, so here we go. So now let's take a look at systems. You guys have done a nice job so far. Here we go. Y is less than or equal to 4x minus 3. That's our first part of our system. Otherwise, I was going to say first part of our system. Negative 2y is greater than x. Okay, so here we go. I need to get my colored pens out. Okay. So let's go 4x minus 3. That's an old one. We've done that. We just did that. One just like it. And I'm going to go ahead and... Oh, does anybody need any playing cards for straight edges? No. You'll do one? Okay, because I handed out a bunch before. Just, here we go. Oh. Anybody else? Going once? Okay. Nobody commented that I at least wasn't wearing a polo today. I just didn't. Somebody gave me a hard time about always wearing polos the other day. I'm like, well, here we go. Let's not wear a polo today. And the pink dog socks. But the pink really doesn't match the lavender, so I'm kind of embarrassed. Well, yeah, I know. You just can't. Yep. Yeah, usually that's how you see people's socks, is to look at their feet. Okay. So here we go. So here's the thing. Don't shade yet. Let's get our line graphed. And let's not shade. Because if we shade like crazy, this is going to get messy. It's going to look messier than your rooms. Or I should say messier than your closet after you clean your room. Trust me. I know. So here's what we're going to do instead of shade. We're just going to put little arrows here to remind. Oh no, I'm going the wrong way, aren't I? It needs to go down. Too busy trying to make jokes about your bedroom being so dirty. Okay. So we're shading down. If I shade that whole thing, then it's going to get ugly for this next part. So negative 2y is greater than x. Well, let's divide by negative 2. So y and negative 1/2 x. What do we have to do since we divided by a negative? Flip my inequality. You got to flip that inequality sign. Don't forget to do that. If you do that right, well, then you'll be able to shade up or down fairly easily. So let's go to a different one. Let's go to green. So y is less than negative 1/2 x. So 0, 0. Down 1 over 2. And which way am I going to shade? I'm going to shade down because it's y is less than. Yeah, you're going to shade where they both are. Okay? So what we have is we have 4 regions here. The right top region, the left top region, the left bottom region, or the right bottom region. Which is it? Left bottom? Right here? Yeah, this is the one. This is our solution set. Okay? This is going to be important later on, so I'm going to stress it right now. If we pick any point in here, what the heck? Let's pick something that's easy to plug in. 4, negative 4. What the heck? 4, negative 4. Which inequality should it work in? It should work in both of them. So if I plug in 4, I get 16 minus 3 gives me 13. Is that bigger than negative 4? Yes. If I plug in negative 2y, they give me 8. Is 8 bigger than 4? Yes. So that gives us a clue that we did something right. Here we go. Let's do another one. I've got 3 more planned. I might truncate that a little bit, though. Just do 2. Let's go y is less than or equal to 1/3 x plus 2. Y is greater than x. And we're going to throw in a third. We're going to go y is greater than negative 3. Okay, you can get started on that. And I told myself I was going to change that one, and I didn't. That was frustrating. Okay. I'll try and stay a step behind you here so you guys can work, but then glance up every once in a while to see if you're right or wrong. Now you can start honing in on the portion that is just going to be the solution set. Bless you. Okay, did my computer die again? Hope not. Good. Hopefully it's still recording. Yes, it is. Good deal. Okay, so here's the solution on this one. I'm below the blue, above the green, so then that just gets me focused on this bottom part. And then it's got to be greater than -3. So, what? Yeah, it's a little pocket. There we go. It's a good way to describe it. This is what's called an enclosed feasible region. Okay? This is what we're going to be working. The next section, I will tell you, absolutely. If you cannot do a problem like this, the next section is an impossibility. So make sure you have these skills. Okay? Let's go one more. Last one. Last one. Where is my work here? Okay. Y is greater than or equal to 4/5 x minus 3. Two x plus 3y is less than 6. And then we'll throw in a new one. X is greater than or equal to 0. Wonder what the last one's going to take a look at. And again, I'll let you guys kind of get started, and I'll be a step behind you. There's my first one if you're stuck. -3, and then I go up 4/5. There's some. and x is greater than 0. I think, did I do a review one on that one or not? I did y is greater than 1. Thought I did. Okay, so the last one is x is greater than or equal to 0. That's this vertical line right here. Because if you think about it, this is where the positive x's live, and this is where the negative x's live. So if I describe this, the feasible region is a little old triangle. If we wanted to, we could pick a point in here, 0, -1, and we could check to see if it's going to work in every single one. It works in the first one, it works in the second one, and it works in the third one. I'm sorry, 1, 0. Wow, I can't believe I screwed that up. That was awful. You what? 0, it'd be on the boundary. Okay, so I just like to pick things that are inside. So 1, 0, good, 1, 0, good, 1, 0, good. Okay, there we go. So here's the deal today. This is going to be due Thursday. Why? Because we're not going to check it tomorrow. We got a test tomorrow. And if you want to take your energy tonight and put into studying, that's fine. But it's going to be page 117, 1 through 5, 7 through 10. I expect you to have 9 beautiful graphs come Thursday's class period. Okay? That's it. The rest of the time's yours.